welcome back. We're going to continue our journey into chapter 3 into these numeric summaries. And so in your book, we're in 3.3 here. And so what we're going to move into is to say that different distributions require different numeric summaries. And so the previous mean and standard deviation, what we're going to find out is that they work best when the distributions appear to be symmetric and unimodal. Okay, so in this section, we're going to introduce distributions that are skewed, right? So for example, this picture here, this distribution, perhaps this histogram, this dot plot will have kind of this shape here where it's skewed to the left, right? So it's not symmetric. And what you see here is this yellow bar is that this mean gets pulled in the direction of the skew, okay? And in this picture here, we have a distribution here where it has something similar to this shape where it's stretched out to the right or stretched in to the right. So that's called right skewed, right? And what we see is here this mean gets pulled out with the skew. And so what this is kind of hinting to us is that the mean could be a misleading measure of typical value or center when the distribution is skewed. Okay, so if the mean is not a good measurement, then that means also the standard deviation will not be a very good measurement for the variation. Okay, so when you have a distribution that's skewed, typically what we're going to look at is something called the median here, okay, in the green. See these in the green? And you can even kind of visualize. I think it's just visually, it looks like a better location for the center, rather than the means here. Okay, but let's get into some of these other numeric summaries we use to measure center for these distributions. So the first one is the median. Okay, the median. So what we're saying is, okay, we know our distribution is definitely has some skewness going on. Okay, skew to the left, skew to the right. So it's now like I still want to measure the typical value or measure that the center of this distribution. So we're going to use the median here. Okay, so it says the median provides an alternative way of determining a typical observation. Okay, it says the median of a sample is the value that would be right in the middle if you were to sort the data from smallest to largest. Okay, so pretty much you have your data, you sort it out from from smallest to largest, and the median would be a number such that 50% of the observations would be above this number and roughly 50% would be below. So here are just two very simple examples of how we compute the median. Okay, there's no real formula for it. It's more of just like a procedure. So here we have ordered these observations from smallest to largest. We go from 1, 3, 3, 6, 7, 8, 9. Okay, so here what we first do is we count how many observations we have. 1, 2, 3, 4, 5, 6, 7. So this is an odd number of observations. So whenever you have an odd number of observations, 7, 5, 33, 43, 47, the median is going to be the center value there. So you see the 6 here, this fourth observation is right dead center of the data. And so roughly, we have 50% of the observations above, 50% below. So the 6 here would be our median. That would be our measure of center or our typical value for this data set. Now, in another case, for the median, you see here we're taking the average of two numbers. Okay, we're adding these up and dividing by 2. Now we're going to do this when the number of observations is even. So for example, we have 1, 2, 3, 4, 5, 6, 7, 8 observations. So it's an even number. So when you have an even number like 10, 12, 100, 102 observations, what the median is going to do is going to find the middle 2, right? Really the middle's right here, okay? Because there's 4 here and 4 down here. So the middle's here, but there's no number here. Okay, so what we do is we look at these two here and we take the average of the two, and that will give us the median of 4.5. Okay, so both of these measures, so what this median is doing, you know, it's another measure of center. And if the distribution is skewed, we're going to use the median instead of the mean to measure the center here. Okay, and just note really quick, imagine if I had changed this number here. I'm sorry, imagine if I changed this number 9 into 9 million. Okay, would it change the median at all? And the answer is no, because whether it's 9 or 9 million, it's going to be the largest number. It's going to be in this location here. So 6 is still going to be the middle number. It's still going to be the median. And so that's just a simple example of how the median is not influenced by these larger values, or it's not very influenced by the skew. Okay, so now what we'll do is look at an example here. So the nice thing about the median and like the mean is that we can easily plot these onto our graphs in StatCrunch and compare the two. So in the pictures that I was showing you earlier on the distribution, they were labeling the mean and the median, which provided a nice visual, and we could do the same on StatCrunch. So here was a histogram of the calorie amount for burgers, and you can see, remember, out here was Sonic Burger, and down here were the White Castle calorie amounts. And so what's in green is the mean, the average calorie amount. And if you look at this distribution here, I mean, it does appear to be skewed to the right? It's kind of stretched out thin to the right here. And here in green we have the mean, and in red we have the median. So right away you can see here that the mean is definitely being pulled in that direction towards the skew, right? Whereas the median is more likely to stay put. So if we look here, the median here would be 515 calories, whereas the mean was around 530 or 40 or something like that. It was a much larger value. Okay, so these appear to be close together, but in the scale there's quite a difference between the mean and the median. So, you know, going back and looking at these examples, maybe, you know, we should be looking at the median more instead of the mean. And so, I mean, these are just, you know, we're just saying for skewed distributions, the mean will be pulled in the direction of the skew, right? And in these cases, the median is the preferred measure for the typical value. Okay, because obviously in this distribution it's left skewed, okay, like we saw previously, it's kind of pulled out that way, and so the mean is influenced by these larger values out there, and so it's attracted to it, so it gets pulled out here, right? Whereas the median stays put, and overall is just a better measure of center in this case. If your distribution you know, appears to be more symmetric and unimodal, then the median and the mean are the same. Okay, the mean and the median are the same, but preferably we want to use the mean. Okay, and actually the mean is more appropriate for a symmetric distribution, and then of course we can use like empirical rule and our standard deviation in these cases. And then of course if it's right skewed, the mean is going to be pulled in this direction because it's being pulled by these larger values out here, whereas the median is going to stay put. Okay, so the median would be a preferred case here. So I mean, these pictures are like the textbook pictures, and and it's obvious as far as which case you're going to get. As you've seen in our analyses, you know, it's not always so straightforward, but we try our best, okay, to see the pattern. In this example, I just want to show you, we were looking at home prices previously in California, and so in this example, I created this dot plot here for the home prices, and I just want to go on StatCrunch just to show you how I did that. Alright, so here we have the data for home prices in 2009, and we've seen it before. So I'm just going to show you how we can easily graph. We can graph the distribution while adding the mean and the median to the graph. So I can graph here, and I can do, what did I do? I did a dot plot. And I want to do dot plot for the price, okay, because that's a numeric variable. And here, down here, you can see we have the markers here. Right, so here I want to do mean. The mean is green, okay, and the median is red, okay. And there's I guess there's other colors you can pick here, but we'll do mean is green and median is red. Okay, so we go ahead and compute that, and that's the graph that we get there. Okay, so you see quite easily we can see this graph. Okay, and what you can see is that, you know, this graph does in fact appear to be skewed to the right. And there's also, you know, these potential outliers in here. Okay, these potential outliers. So it's kind of like a double whammy in terms of like pulling the mean. Okay, sometimes just the skew could be enough to pull the mean, or even just an outlier can be enough to pull a mean. Meaning that this here could be like perfectly symmetric, unimodal, but just one really large value can really pull the mean. Okay, so in those cases we want to use the median here. So if you just hover over that value, we get a median of 295,000. Okay, and here we get the mean of 383,000. And so if you were just to examine these by eye, they look very close together, but once you actually see the prices, it's almost $100,000 difference. Okay, so if I'm trying to like convince people to come and buy homes in my area, we're definitely going to be reporting the median, and plus it's a much better measure of center here. Okay, or a much better measure of what's the typical home price in this area. Okay, so, and home price is always interpreted with summarized with median. So if we just look here as far as what we created, I mean the average is 383,000. Right, the average home price in this San Luis Obispo County, I believe it was 383,000, but the median is 295,000. So we have two measures of center. Which one do we want to use? Well, this is obviously highly skewed, and there are outliers, so we're going to use the median. Okay, the median is a much better representative of the typical home price in this area. And you compare these, I mean, it's almost $100,000 difference. Okay, almost $100,000 difference. And so remember, I mean, what else does this median mean? Remember, it's the middle, right? The middle of all the home prices, right? So if you were to sort the home prices from smallest, cheapest home price to most expensive home price, this would be the middle. So what it's telling you is that roughly 50% of home prices in this area are actually less than $295,000, while the other 50% of the home prices are actually larger than $295,000. Okay, so we're using this median as a new measure of center. So what about the variation, right? How do we talk about the spread around the mean, right? So in the previous examples, in the previous video, we had the mean as a measure of center, and then we had the standard deviation to give us the expected difference from the mean. Okay, so now for the median, in terms of measuring spread, we're going to look at the IQR, or the interquartile range. Okay, so interquartile, so it's just saying the inner quarters. So pretty much like the median, what we're going to do is the median splits the data in half, and then we're going to take the half of the half. So pretty much we're just splitting our data into quarters, and we're just saying, well, let's look at the middle quarters. And then the middle quarters, that's going to be like our other version of standard deviation. Okay, so it says here once again, when a distribution is skewed and you are using the median to measure center. An appropriate measure of variation, okay, so it's saying it's not standard deviation, it is called the interquartile range, or usually you're always going to see it as IQR. Okay, and it provides how much space the middle 50% of data occupy. Okay, so in order to calculate this IQR, let me walk you through the steps very quickly as far as how we find this IQR. Okay, so what first thing we do is we find the median. Okay, so here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have an even number of observations. So to find the median, I take the middle 2 and take the average of them, right? 70 plus 72 divided by 2, that gives me 71, the median. So now what I'm going to do to find the interquartile range is I need to find the first quarter of the data and the third quarter of the data. So what I do with this lower half is I'm just going to find the median of the lower half. So here I have 1, 2, 3, 4, 5. So I have an odd number. So this middle number is the median of the lower half. This median of the lower half is the first quarter, okay, which is 64. So now I repeat the same process for the upper half by finding the median of the upper half. And once again, it has an odd number of observations. So this middle value, 77, is the third quarter. So pretty much what this Q1, it's a quartile, okay, and it's helping us split the data up into quarters. But what it means is pretty much 25% of the observations are less than 64, and 75% of the observations are greater than 64, right? And the median is like the second quarter, right? And 2 quarters gives you a half, right? So it's just saying for the median, right, 50% of the observations are below and 50% of the observations are above. And then of course we could take it all the way to the third quarter, right? So this is the larger quarter, third quarter. So the third quarter is just saying, well, 75% of the populations are below 77 and 25% are above. Okay. So, but we're only interested in these 2 quarters here. Okay, the interquarters here. Okay, so what we want to know is for the middle 50%, because remember from here to here is a quarter and from here to here is a quarter. So this here, right, is the middle 50% of my data. So what we want to know is what's this interquartile range? Okay, what's the length of this middle data? And that's what we do here. 77 minus 64 is equal to 13. Right, so it's saying, hey, the middle 50% of my data, it ranges by 13. Okay, so that's a measure of spread when we're using the median, okay, in the interquartile range. So if we were to apply this to the home prices, right? So we already know what the median home price is. So let's find the interquartile range, right? Pretty much the amount of variation around the median. And so what we're going to do here is we find the first quartile. Okay, so Q1 represents the first quartile, like the first quarter. Q3 represents the third quartile, the third quarter. The median, it's really the second quarter, but the second quartile, but nobody calls it that. It's always called the median. Okay, so in StatCrunch, I'm able to find the median, first quarter, third quarter, and it already takes the difference for me. Okay, the interquartile range. Right, so pretty much if I'm just using the first and third quarter, I could just say, well, 50% of home prices are between 199,000 and 429,000. Right, so that means and then here, if I'm just want to interpret the IQR now, it says, well, the middle 50% of house prices varied by as much as $230,000. Okay, so now we have interpretation of standard deviation, I guess, when we're using the median for skewed data here. Another measurement that we can use that's very simple and rather crude, but the reason we do it is because it's just fast, is we could just look at the range. Okay, so the range, of course, can right away give you a the pretty much the total variation in the housing prices. And so the range is just a matter of finding the maximum housing price and the minimum housing price and taking the difference of those. So here we have the min in this data set was 26,500, and the maximum for this data set was 5,499,000. Okay, so the range here is just the difference. And so this is just saying, well, the range of home prices is 5,472,500. Okay, so this is not as reliable as the interquartile range, because I mean it's saying that the range is from here all the way to here, but really these values are, you know, they don't really fit, they're not consistent, kind of like outliers, right? This interquartile range, you see this range spans 5 million, whereas the interquartile range spans 230,000, right? This is much more accurate in telling us what the typical home price would be in this area, right? It's saying this varies by this amount, and you know, you really could find a lot of homes between 199 and 429,000, right? Versus scaring someone by saying, hey, yeah, they might be around, it could be around $5 million, right? Okay, so I mean, pretty much we've presented two cases here. Either you use the mean or the median, or we use the standard deviation or the interquartile range. So it comes down to comparing measures of center. Okay, so it's just saying in these cases we're always going to look at the shape first of the distribution, right? If it's skewed, we use a median. Okay, if symmetric, then we want to use the mean. Okay, but also we have to look for outliers, and if there are outliers, right, you know, there's ways we could check for them using we can use different tools for using them, but what is the effect of the outliers, right? So if these outliers are very far away or very kind of influential, then maybe we should be using the median, right? And then there's other things to think about too, is how many modes are there? Right, I mean, if you have two modes in your distribution, like two humps in your graph, I mean, really, there's two means then, right? Or two medians then, really. I mean, we wouldn't call medians, but you know, there's two typical values, right? Not just one. So maybe what we're doing isn't appropriate, right? So here we don't really quite have a solution for this class, but in other classes like future stats courses, if you take them down the road, we can answer these questions. Mainly the solution is what we call cluster analysis, right? Meaning that there's natural groups in our data, and we should examine them separately and separate them. Okay, and also too, in this case, if we're comparing two groups with different shape distributions, we must proceed with caution. So we've done that when we were comparing like the cereals, right? Cereal for middle, lower, top shelf, and the sugar amounts. I mean, when we saw those dot plots, they were all very different, right? They're all very different. So it says you should be very careful in comparing those two distributions. So, I mean, as far as outliers go, so here we see something that's perfectly symmetric almost, right? Perfectly symmetric. But then we introduce a group of outliers. Okay, and so in this case, we see that the mean, which is in green, is still highly affected, right? The mean will say your center is about right here, right? But the median does a much better job in saying that the true center is about right here. Right, so the median say, hey, look, your true center is right here. Forget about all of these. right? They're not even consistent, right? Something's up with these, but your true center is about right here. Your most typical values are going to occur here because there's such a high amount given by the height of this here, right? So in these cases, right, where your outlier has such an influence here, we want to use the median or something like this as well. Okay, so this histogram is of standardized values, right? And so what we have here is that this z-score here, I guess, is like a -5, right? It's a very very much an outlier, right? So in this case, the median would also be most appropriate. But if you look here, it looks, more or less like a symmetric kind of distribution, right? And then you just get this spike here. So that outlier is enough for us to say, well, we should use the median, right, rather than the mean. Of course, we would investigate what this point was, make sure it's not like a typo in data entry or, just some kind of mistake. But if it's not, I mean, ideally we keep it there. Okay, outliers are not bad. Okay, they're just things that we need to look out for and we need to adapt our methods to. So that way we catch the true phenomenon that's going on here in the study. And so just to revisit our distributions here. During our last class, we were using the 68% empirical rule, actually, for the top, middle, and bottom shelves for the cereals. Okay, and so what these dot plots are the sugar amounts. Okay, the sugar amounts. So last time what we were doing were these empirical rules, and if you look here, I mean, the empirical rules are using the mean and standard deviation, and what they kind of require is that we have something that's unimodal and symmetric. So if you look here at the bottom shelf, the mean is much larger, right, than the median, right? There's a big space here. So this is kind of indicating that it's skewed to the right, or maybe there's an outlier here, right? And same thing here with middle, right? So this says the mean is bigger than median. It's indicating a slight skew to the right, or maybe there's just outliers present, right? And for the middle, right, the mean is a lot smaller than the median, right? So maybe that's indicating that it's skewed to the left now. Okay, skewed to the left. So see, it went red, green, now it's green, red. Right, so it's skewed to the left. So this is also indicating, maybe we shouldn't be using the sample mean and standard deviation or the empirical rule in comparing these distributions. Right, and of course for the top shelf, we kind of get the same thing here. Right, here's our median, here's our mean. Maybe a slight indication that's skewed to the right. Right, so in this case, maybe we should be looking at medians or interquartile ranges. Right, so if I just look at the medians here, right, so I pulled these from StatCrunch. So here, the median for the bottom is 3. So it means 50% of the sugar amounts are above 3, and the other 50% are below 3. Okay, so I'm definitely not going to pick a cereal box from the bottom shelf, right? And for the middle, though, right, so the median's right here in red. Okay, it's saying roughly 50% of your cereal boxes in the middle are gonna have sugar amounts more than 12 grams, right? And of course here the top is saying, well, 50% are gonna have more than 6, right? So maybe in terms of which shelf to pick, I mean, it's very obvious, a little bit more obvious here, that this median is so much larger, and that 50% of the sugar amounts are greater than that, then maybe I'm going to be picking the middle shelf. Okay. So this is just a way to attack this problem using the median. Okay, and we will use it also using the interquartile range, but in form of a box plot. Okay, but we'll do that next time. Okay, I think right now it's time for a little follow-up, and then in the next video I'll show you how to construct a box plot.